And I should say, Carlton has more than 25 years of experience in designing systems relating to multimodal interaction, distributed systems, and spatial computing. So thank you very much for joining us. So this is, obviously a very broad space of technologies and areas that we're going to be touching here. But what we would like to do in this panel is get down to the core techniques, ideas, and remaining challenges. We are just starting a multi-year journey here in the CISL. And I think it's very important for us to kind of take stock of where we are and then say, what are the big next steps and breakthroughs that we need? So, Rich, you've already given us a very good overview of some of the directions that we could go in. I would like to ask the remaining panelists a few open questions so they can start with a position based on their own work, and then we can go into more specifics here. So let me go back to the idea of augmenting human intelligence, which is the theme of this conference, of this colloquium. Obviously, the goal of cognitive computing is to augment and not to replicate. So the notion of getting machines to complement people and doing things jointly is core to this idea. So let me start with a couple of the folks who've been working on those topics first. So maybe I'll start with Marge. You've been working on a range of collaborative tasks, including the medical domain, and you obviously you've seen the strengths of humans and machines. How do you see this world of humans and machines collaborating and coming up from the experiences you've had and the projects you've done?
Well, I think that one of the most important things to do is, if we want our machines to act as collaborators with humans, is to endow those machines with the kinds of models that humans have of a domain of the world and how they reason about a domain and the world, and their interlocutors, by the way. And I think that that's one of the missing pieces in how we're approaching things such as language understanding. That is, if we want a machine to understand language, it's not just looking at text, huge volumes of text. What it needs to do is it needs to actually incorporate the meaning of that text, the interpreted meaning of that text, into its model of the world and into its understanding of its plans, its goals, and what it's trying to do with its human collaborators. And basically, in the work that I've done, one of the most striking things has been, for example, in the medical domain, in trying to create physiological simulations of diseases. What we found was you cannot go to the medical literature, even a doctor cannot go to the medical literature and actually get sufficient information from the literature to create a simulation of a disease. Why? Because a person's understanding of a disease, we don't know how the body does it, of course, but a person's understanding of a disease is lots of bits of information glued together by an understanding of the world, hypotheses about unknown things, and many, many other things. And so therefore, I think we have to be very serious about the disconnect between the data that we find available in even large data resources and what has to happen to that data in order to create a really comprehensive, usable model within an intelligent agent's mind.
That's a great way to put it. I think it's a foundation for many of the other things we're going to talk about. So, Henry, you've also been doing a lot of collaborative problem-solving types of activities, and you've been thinking a lot about the roles of humans and machines in various kinds of activities, like negotiation, for example, things like that. So can you tell us a little bit about how you think about the role of humans and machines in these collaborations?
Sure, yes. I agree that humans and machines have to collaborate. I agree with everything that Marge said. Particularly where we're working to understand human common sense knowledge, which is just simple knowledge about people in everyday life. You sit in a chair, water is wet. And these are the things that sound silly if I say them to you, but a computer doesn't know them. A computer with all the big data in the world and all the deep learning in the world, still doesn't know those kinds of things. And very often we get tripped up because we always want to rush to the most complicated, most technical, most detailed, most data-like knowledge, and then we forget the simple stuff. And what humans are good at doing is the simple stuff. And so I think we need to understand knowledge in a broad spectrum, from very technical detail that you would find in a textbook or an encyclopedia, down to just simple knowledge that a 5-year-old would know. And I think in order to really get good cooperation between humans and machines, they don't have to be exactly like humans, but they do have to have some cognizance of knowledge that's all the way along those spectrum.
Excellent. So I think the two of you are talking about the knowledge and the reasoning side of this discussion, which is the AI side. And I want to switch to the HCI side and focus on the word immersion for a minute. And maybe, Andy, I can start with you and ask you, you've been doing a lot of work in in human-computer interfaces. So what is the big deal about immersion? Why do we want immersion? Why do people actually do better when they're immersed? And how?
So I think first off, there's a couple different definitions of immersion. You can sort of go all the way to being, full 3D and having, lots of multimodal interfaces. And then there's just the simpler version of immersion of having, say, a lot of data around you, being with your collaborators in a space. And I think the big problem, one of the big problems we have, and we will continue to have, is that no matter how big our screens are, no matter how many pixels we have, there's always going to be more data. So we're constantly going to be overwhelmed with that. And what we really need is the intelligence of our friends, our collaborators, our technology to help us get a handle on it, to help reason with it. And I think where immersion really helps us is that if we have people from multiple disciplines in the same room or in linked rooms, we can show multiple representations. At EVL, we spent a lot of the 90s working in caves trying to put all kinds of data into one representation that people could share. And it just will never work. And so in the 2000s, it became, okay, let's have more resolution, let's have more people in the space, give each person their own representations. Because what it lets us do is take what everybody thinks they know in here and forces people to put it on the screens, forces people to share it so their collaborators can look at it, can say, well, why is that? Or even have your data force you to confront your own supposed knowledge and understand, well, wait, that doesn't fit. Why doesn't that fit? And maybe someone else in the room knows why it doesn't fit. And so having a lot of this data around us, and this in the old technology goes back to a lot of the work on war rooms that the University of Michigan did in the 90s. Having these multiple representations, having the same data in different forms, being able to spatialize it so we can remember that the temporal stuff is over there and the geospatial is over there, helps us work together faster, helps us work together more efficiently. And we've had groups that we work with that'll come in, they'll use our spaces to evaluate their data, to go through their hypotheses, to work together. And they'll literally say that they can get more done in an afternoon than they could with 6 months of conventional technology. Because there's just something about being with your friends in the data that really forces you to focus, forces you to really deal with those problems that maybe you can't do yourself, but together, with our friends, with our tech, with our high-speed networks to get us this data and these great pieces of big iron to do the computation for us, get us to answers quicker and better.
Well said. Carlton, I think you've done a lot of implementations of these immersive environments. And of course, you've probably done it in the context of industrial settings, and you've probably seen how people work with them and so forth. So share with us some of the experiences you've had in the implementation of these, please.
Sure. And if I look back, the data-rich immersive environment isn't necessarily a new thing. One of my favorite examples is a couple blocks away from my office in Boston, which is a Fidelity chart room, which dates back more than 50 years, where they would go in and on large sheets of paper, and it still exists to this day, they'd be able to plot financial data in various ways with pencil and pinprick and things like that. And what I've been working on the last 6 years is sort of how do you bring kind of 3 generations of technology into that. First of all, digitizing that space so that, one, you can reuse the space. You walk into it and suddenly you can bring up all the data that was there when you had the last meeting. And everybody can put up and project their version of data, but also create that collaborative work environment where everybody can have that conversation. The second piece that we bring to it is something that we call infopresence, sort of beyond telepresence, of how do you connect those rooms so that multiple people on various continents can be joined into that conversation at the same time. And really allowing you to get to, when we first thought about it, we thought about things like, well, how do you save money on plane tickets? But it's really not that. It's about how do you get the right experts and decision makers into the same immersive environment at the same time so that you can get to that decision faster. And then we've been fortunate over the last 2 years to be working closely with IBM and being a technology provider of things like Dr. Kelly showed the picture of the immersion room earlier, where we are now bringing not just those collaborative experts, human experts into that room, but now cognitive experts into that room and creating that new level of conversation, getting to those, being able to consider things that maybe the humans didn't consider, or at least being able to get to those decisions a lot faster with a lot more information.
Great, so I think that gets to the heart of the question about collaboration, and how individual work and collaborative work are fundamentally different, right? It's, in collaborative work, it's what happens between the entities that are collaborating, people and machines. And there's many studies about why putting the best people in a group may not create the best group necessarily, right? It's a group that has to work together to solve a problem. So maybe I'll go back to you, Rich, and some of your examples. So tell us, how you see, in each of the scenarios, in fact, in all of the scenarios that you've all been talking about, I would like to know how you see collaboration as the challenge, right? And collaboration as the, effective collaboration as the end goal of what you'd like to get in these cognitive immersive environments. How much of a difference will that make?
Well, I think it'll make a huge difference. I think that, we're fundamentally confronted with having to fuse different types of information from all sorts of domains. If you think of the department, we got the naval domain, the air, space, ground, and then increasingly this cyber domain. And even those activities, which relate pretty much to the department, then have to be fused with tremendous information feeds on what else is going on in the world. And there's so many commercial information sources that would, you'd hope, blend together to derive situational awareness. Now, clearly it's beyond any one human's ability to synthesize all of that information or even collect snippets of it. So collaboration is absolutely key, because often the game that we need to be engaged in playing is playing out simultaneously across all those domains.
Okay. Andy?
Well, one thing I think is important to point out is that, I fully love these rooms. I think they're great for teaching and for doing research and helping domain scientists, but they are just part of a continuum that, people are still going to work in their offices with their laptops, and maybe they'll have a 4K stereo OLED screen there to, have more data in that space. But, we're still going to have offices, we're still going to have meeting rooms, we're still going to have people doing individual work. And a lot of the trick with this is, how do you maximize each of those points in time? How do you get work done individually and quickly be able to share it with a group, or have a quick meeting, down the hall? Because a lot of these spaces, as great as they are, they're still not, for a while, going to be where you are until we get the really nice digital wallpaper and get all that future. So we want to make sure that people aren't confronted by this inertia and this problem that, well, I'd like to go there, but maybe I have to schedule it, or it's down the hall, or it's one floor up in my building. That won't work. And so, if I think a lot of these, the way we're linking data together, we're linking our friends together through the networks as well, helps bridge that gap. But, fundamentally, we do get the most work done really face-to-face, looking each other in the eye. It's like, wait, why do you look confused? What are you looking at? There's so much bandwidth there just between humans that we need to make that collaboration effective. And, I think we're getting there. And I think having, these, extra agents in the room that can help us, that can sort of take the place of, those really smart people in the room right now. Because I think we have a lot of, smart spaces.
Yeah, do you have any examples where, people have shown the improvements possible in effectiveness, for example?
Well, I think we've seen it.
Anyone, actually.
I mean, it's just, you know, once you're there and when you're in the zone, basically, I think that's what these rooms really help, is that if you've got the tech right and you've got the people right, you really start coming up with hypotheses and you're checking them off, and someone else in the room has that data on their laptop, and you know, they can solve that problem real fast. Or, you know, now we, you know, get access to these resources and we can bring in extra data quickly. So we're not thinking about what could the answer be. We've got the data coming in. We have someone who knows enough about that data to answer those questions for us.
Any other comments? Yeah?
Yeah.
Yeah, go ahead.
Yeah, I think Andy got it with that in the zone kind of thing. That we've all had these moments when you're really cognitively engaged in a task, when you're really concentrated on it, everything else kind of melts away. You have all the people you need and all the resources you need, and then problem solving goes really fast. It's what Mihaly Csikszentmihalyi called the flow. He wrote a book called Flow about that. And it doesn't need media. You know, you can do it with just two people sitting in a room and no media, right? But the perceptual immersion, which is usually what we talk about as immersion, we need to add to that a cognitive immersion, okay? Where everything that's relevant is there, things that aren't relevant aren't there, that you have some intelligent agent that can anticipate what you need and gets it at the ready, just like a personal assistant would do. And I also think we need to rethink the nature of collaboration. As technologists, we often get accused of ignoring the human side of collaboration. So I'm trying to pay attention to that these days. I'm studying negotiation, conflict resolution, psychology, cognitive behavioral therapy, you know, all these kinds of things. And I think there's a lot of new and interesting ideas in these fields that are all kind of disconnected. And I think the thread of it is that as a result of the technology, so there's always a trade-off between cooperation and competition, right? Neither one is right under all circumstances. But technology is changing that trade-off in a fundamental way, I believe. It's increasing the benefits of cooperation, and the supposed benefits of competition are kind of decreasing, okay? And I think we need to recognize that and change our people procedures too, okay? In most meeting-driven cultures, there's only two procedures. One procedure is you just go around the room and ask everybody what you think, and you take a vote. I call that a mode and vote. And the other one is where you have some authority, and the authority is going to make the decision, and everybody just advises the authority. I call that plea and decree, right? And neither one of those really is the best way to encourage creative problem solving among a group of people. You don't understand what their expertise is, you can't get new and original solutions. And there's a bunch of people in the social sciences and that have very good people procedures for encouraging collaborative problem solving. But they do it all with pencil and paper, and I'm sick of colored Post-it notes on the walls. You know, and they don't really have very good technical means for being able to support the new kinds of collaboration. So I think that's where the frontier has to be.
You know, yeah, that's incredible. Not only is this kind of a journey and a vision of the future of human-computer interaction, but it's a vision of the future of human-human collaboration and human-machine group collaboration, where multiple people and multiple machines are participating, right? I think that is a powerful new vision, and I think it's got to be tested, and it's got to be evolved in many scenarios. So I might ask all of you actually to talk about what would be the best way to proceed in this research agenda in your mind. You know, where would be the places where you would go, set up the right scenarios for testing this? You know, what kinds of technologies we may need to add to get the biggest bang for the buck, right? What is your view on how we should proceed on this research agenda? Any takers?
I'll take. Okay, so I think one of the interesting scenarios could be a diagnostic theater. So you have a patient, the patient is connected to whatever kind of monitors would be found in any kind of a hospital or doctor's office. And people are collaborating in trying to diagnose the patient and look for directions of treatment. So how could the system help? Well, we can all kind of envision that, yes, it would be good to have data of different types kind of at the ready. A system would be able to provide that. But I think even more importantly is that the system should be able to do the kinds of things that humans are not particularly good at. And we've heard before references to things like biases, so decision-making biases. So for example, a group of people trying to decide about the diagnosis for a patient might be under the small sample bias, or they might be under another bias that is kind of affecting their judgment. They might have an intuition that there's a right answer, but not have enough data to support that intuition. And this is where the machine could actually, I think, in the near future, be very, very useful, because it could actually act as the force to give an objective view, an objective data-driven view based on, I would say again, some kind of a model of the challenge, a model of the domain, to actually say, no, actually, I know that there exists such a thing as a small sample bias. And I know what the conditions are that tend to lead to a small sample bias. And based on the fact that I've watched you interact, you group of people interact over the last, I don't know, 5 months together, solving different cases, I think that you're actually at this point under the effect of the small sample bias. Here's a warning and how I'll help you to actually trace back if you actually are under this kind of decision-making hindrance.
Yeah, I think that's a great direction. By the way, if you have questions, I'm going to open up after the next comment, so you might want to start lining up as well. So, any other opinions on how should we proceed on the research agenda?
So I could give another example.
Yeah.
So we've been working a fair amount with the city of Chicago. So a lot of cities now are putting a lot of data out for everybody. Not just data on crime, data on economic data, all the census data, and that's a really rich platform for a lot of different groups. Transportation groups interested in poverty, in education, in crime, in open access to government, to come together and actually have conversations that are really backed up by data. But I think one word that I haven't really heard a lot talked about today has been about uncertainty. And, yeah, we have a lot of data, but a lot of it, what's the error range on all of this data? That, having facts may not be incredibly important if those facts are a little vague. So I think, the more different test beds we can create in these different environments and get different people involved from different disciplines, I think we start to narrow, get those ranges pushed in and really see what do people need, and especially what do people need to know about that uncertainty in the data. Because I think a lot of times, and especially as visualization people, we present things as truth. It's a bar chart, it's a line chart, and we don't often show the uncertainty in that. And there's so much uncertainty out there that we really need to be showing people, and we don't know how to do it.
And it's something that you can, if you have the luxury of a lot of pixels and a lot of space, you can subdivide and sort of repurpose how you're going to do that. You can I have some actual data over here, and I have my cognitive agents coming up with some hypotheses around there, and if I want to drill down into that, I may have kind of the data that they're bringing to the forefront for why they made that decision, and so you can see kind of what they're suggesting based on what that data is, but then you can also look at, okay, what are the documents that you're mining to get to that decision, and provide all of that for the people in the room so that they can discuss around that and get to a more informed decision.
Okay, so if there are questions, you should come up. So in the meantime, are there any questions? Yeah, go ahead.
Would anybody on the panel want to comment on the needs for development the workforce of people who would be working on all these issues that you are discussing?
Mm-hmm. Mm-hmm.
Well, I definitely think that we have to create a workforce of knowledge engineers. I think that, there are no proposals on the table that I know of to say, okay, we have to automate computer programming. And so therefore, all of the software engineers we're going to fire right now, because it's really not any fun if we have people actually being trained as software engineers and doing the software engineering. I think that over this history of this, this AI winter, the idea of actually manually doing something with knowledge, creating models, either manually or semi-automatically, has become so undervalued that we don't even think of this as being a need. But in fact, I think we do have a tremendous need for actually creating a workforce of knowledge engineers to take very seriously the chasm between data, and as we heard Dr. Kelly say, there's a massive amount of data that we're not using right now, it's just being buried. There's a chasm between data and between knowledge. And in order to actually be able to eventually bootstrap the automatic production of knowledge from data, we do have to get that bootstrap process going by very serious knowledge engineering, by people who are going to be as serious and as skillful and as ingenious as the computer programmers have been to date.
Yes, go ahead.
Well, I think it's also important that we make these spaces as flexible as possible and make sure that people can bring their own tools to the environment. So the tools that they're used to and how they process that information, they can bring those into the environment. The advances that we're seeing in natural language processing, so that you can be asking the cognitive agents, or gesture recognition, how you can be referring to things in the room, or how you can be, through natural means, kind of get a cinematic knowledge of, flying through a database without having to learn a whole bunch of additional skills, by making the environment intelligent enough so that you can bring your knowledge in there and not have to learn a whole bunch of added skills in order to get the added leverage of a cognitive immersive system.
Okay, go ahead, Henry.
Yeah, so we've had this vision that many people have spoke about already of the computers getting the data, giving you the visual sensation, doing the drudge work, right? And then the task of the human is to integrate, to understand, to bring the moral and ethical components to it and stuff. Okay, so if that's going to be the collaboration of the future, how do we train people? Well, let's stop training people to be machines, right? Because that's what the factory model of education that a lot of schools have, of constant testing and hill climbing on the test scores, and basically we're training people to be machines, right? And what you want to do is train people to be creative, inventive, collaborative. And so you need to we need to move more towards exploratory learning and those kinds of learnings that help people get the skills that we know are going to be necessary to collaborate with the machines.
Excellent, excellent. Another question. So I think this will be the last question.
Having worked in IBM research for a very long time, one of the problems we see is the role of culture in people participating in meetings. And typically, we have 12 different labs across the world, and we have multiple languages being spoken in the labs. And one of the common problems is 2 or 3 people who are really loud and who can talk in English, really dominating the conversations and the decisions. And so this is on the phone typically, and you'll never hear about any of them except the 2 people talking. So one of the questions I have is, if the environment is able to see the fact there are 12 people in the room and they talk different languages, it'll be pretty neat if the people who are speaking in Japanese actually spoke in Japanese, and so they can be completely expressive in what they're saying, and the other people better listen to Japanese, and there's a way for taking that and conveying what they said in a very effective way to the rest of the people. And so the different people speaking different languages is not really an impediment anymore. They can be as natural as they're going to be.
Well, that's been one of the big problems or questions of natural language processing since its inception right after World War II, when it was hypothesized that maybe this is just like code breaking and will knock off machine translation in no time flat. Well, it turns out that language is very ambiguous, very elliptical, full of implicature and all other kinds of problems like that. I'm absolutely in favor of going after deep meaning, which is meaning that essentially is knowledge. So if we have an intelligent agent in this room who is taking in language inputs, no matter the language, actually understanding the meaning of the language and then generating into different languages, that would be absolutely just the holy grail of natural language processing. It's not currently being pursued very widely in today's natural natural language processing community, the approaches that are giving better benefit in the short term are statistical approaches trained on parallel corpora more. And so it doesn't seem that in the very near future you're going to have, unless there's a sea change in how we approach things, and I would absolutely embrace that sea change, I don't see in the very near future that's happening. However, if we do want these systems that understand natural language, whether they're understanding natural language of Japanese or English, that shouldn't be the big barrier. It's actually the whole nature of understanding that is going to be the challenge. Once we've got it for one language, it'll come for the others in due time.
I'm going to make a decision to take one more question. Go ahead.
I appreciate it. My name's Colin Garvey. I'm a student here at RPI in the SDS department. I actually speak Japanese and translate, and I use a computer-assisted translation tool, but it's just kind of a rough approximation. It works on the corpora and keeps me in a job, actually, part-time, so thanks. I wanted to ask, I've heard a lot about immersive environments among small groups of collaborative researchers, but I wondered what your thoughts might be on how AI, intelligent assistance, cognitive assistance, might further democratic decision-making processes at a large scale going forward in the future. How might a public augmented with smartphones and other intelligent devices be augmented in their decision-making capabilities at the level of nation states, or nations and states, I should say?
Great question. Any takers?
Yeah, so that's a great question, and I think we need, one of the research topics that I'm working on, I don't have time to talk about it here, is to try to make some decision support tools. So the great thing that we have about the web now is we can have global conversations and global problem solving, amongst people on the web. But the problem is, if you look at, the comments section of the New York Times, it's just one opinion after another, right? And you don't know how these opinions relate. Is people saying the same thing? Are people bringing up interesting points, or are they just, bringing up irrelevant stuff? So I think we could use some help in intelligent agents to help organize large-scale discussions, to make them comprehensible to people who come into them at various times and with various personal perspectives. So I think if we have more software that really takes account, understands natural language, so it understands something about the content of what, and the culture of what's going on, then I think we can have much, much better large-scale collaborations.
Well, thank you very much. I think that was a great discussion. I really appreciate all of your expertise and your perspectives. I think one of the key points to take away here is that fundamentally the cognitive and immersive systems laboratory agenda requires multidisciplinary approaches coming from all over the spectrum. We talked about psychology, technology, sociology, and you name it. I think all of the other fields, domains of expertise will have to come together. So this is an incredible nexus of all of that expertise that will take us to the next level. So thank you very much again for your participation. Yeah?